Okay, in this video, I go over a brief introduction to SIMUL8, going through what we're going to cover in the class, as well as opening SIMUL8 and moving around some basic functionality. First, we at Union in the business school, but actually the entire university, we have a site license. And we have this installed in various labs, primarily BAC 45. But you can also install on your Windows machine. It has to run on a Windows operating system. It does die every 6 months, and these are specific calendar dates, not 6 months from when you install. So if you install it, you're going to have to, and you want to maintain it on your machine, there will be a new password every February and August, and I can give that to you either through a syllabus or just send me a request, and then these are the download instructions. Anytime you start a new model for the class, there's some things I want you to do. It's going to, first of all, realize that when you open up SIMUL8, you can save files and then do anything that you can do any files. You can save those to a flash drive. You can email those. When you do the homework, I need you to submit your simulation files in addition to your output, which is usually in Excel or a report. For the class, there is a default part of SIMUL8 that I don't like, and so we're going to make sure that we set all travel distances initially to 0. And also the clock, I tend to like to use a simple count as opposed to a real physical clock. So I'm going to go through and quickly show you what that means. So here's SIMUL8. I've just opened it the first time. I'm starting new, and I can always do a file, save as, and create a file, and the extension is a .s8. So I can create a file, and then once that file is saved somewhere, then I can move it around, save it, email it, edit it later. When you start a new file, I want you to go under File Preferences, Distance, and make sure you set the travel times to 0. It's going to ask you, do you really want to do it? And you say yes. All this does, it allows us to put our own travel times in and keep those independent of where they are located on the screen. For example, if I put this construct here and another one here, the fact that they're that far apart, the default part of SIMUL8 says that it takes longer to travel that than that. And I don't want to worry about where I put it on the screen. I'll put the travel times in based on what I want the travel times to be and not a function of where they are on the screen. Then the clock, if you right click on the clock, go to clock properties, we're almost always in the class, we're going to use a simple count. If you want to change what that value is, use the simulation time units, and then we can change this to whatever we want. So if I want to run this for 10,000 time units, that's great. And look what happens now. The simulation is no longer a clock, but just a simple count. So if I would run something, run it really slow. But you can see this is the clock. And so that is in time units. And we decide what the actual time units are separately outside of the model. And I'll do examples on that later. But yeah, don't use the actual clock. Use a simple count. It's easier to change. So once you've done that and you've saved the file, then next time you open that file, you don't have to do these. It'll remember those. These are the building blocks. They show up in SIMUL8 over here. This is the things that you pull in. It's object-oriented, so you pull in a block and then you can click on it and fill out forms. So the top four are what we use most often. All of the examples I do in class are based on those. We've got to have a starting point. We get to be God and we get to create, and that's what the starting point block does, is allows us to create things that are going to move around our system. These can be people or parts or cars, but we got to have an origin, a place for those to start, and that's what starting points are. By far the most important parameter that you'll need is the time between arrivals. So if things arrive more frequently, then the time between arrivals will be smaller time intervals between arrivals. And then a KPI is a key performance indicator. It's a statistic. It's a metric we're interested in reporting and managing against. And the one that we usually use or go grab from a starting point block is the number that have entered the system. The next block is a queue. It's a place for items to wait. Queues don't push things out of it, and it doesn't pull things into it. It's passive. You have some parameters. You don't have to put any of these. The assumption is that a queue can hold an infinite number of things, but if you want to force that to be an upper limit, so it's a capacity. A shelf life tells you how long it stays in that before it goes bad or is no longer useful. You can also force things to stay in there a minimum time, and you can also start the model with things already in a queue. The two metrics we look at is a time metric and a count metric, the time in queue and number in queue. Another block is the activities. This is where work occurs. So this would be some type of processing. And so the things we're interested, the parameters are the service times and the distribution of such, as well as how we pull things in and push things out of an activity. So this is where things happen. We're interested in how busy the activities are, which is the percent of time working or percent of time waiting for work, percentage of time that I'm blocked, which means I can't move my stuff, move my work to the next activity, so that means I can't do anything. So we can gather all of those. And then end is where items leave our system, where we no longer are interested in what they're doing. And we don't want to keep our model maintaining all of these different entities, which may be hundreds of thousands of entities that we're managing. And the easiest way is just to get rid of them once we've done what we needed them to do. The metrics that we will gather from an end block is the time in system and the number of work completed. I'll talk about resources later in a separate video, but it's like a floating activity. It allows you to model activities that require a certain item or certain tool or a certain specialty. And then, so think about, you may have places for people to check out, but you might have cashiers that float between a register and then also doing something else in a store. And then how we link things together with routing arrows. So again, I'll have more examples about how to build simulations, but these are the basic building blocks. Reference this. We'll build examples. We'll build 4 in the class. How to do a single server, model a single server system. That's a system where we have one server. Then we expand it to multiple servers. We look at how things move around the system. The default is first in, first out, but they don't have to be that way. We can move things based on a priority. Things that are more important are done first. Then we'll do an economic example. And then the real cool, real powerful that we just touch on is SIMUL8 has its own programming language called Visual Logic. If you've programmed before, then you'll be pleasantly surprised. If you haven't programmed before, this will give you a chance to program. It lets you do things that you can't do with the canned basic logic of an object. So the forms sometimes are limiting, and if you want to get underneath that and program some things that you can't easily model, but you can certainly model with the programming language, we'll learn how to do that. And there's some examples we'll do in the class. Anytime you run the model, we want to be able to run and generate reports. So let me show you briefly how to do that. We're going to add our statistics, our KPIs, by right-clicking on a result of a certain block, and then we run a trial to generate a report, and the result we can copy to Excel and paste it to a clipboard. So let me do that real quick. So I'm just going to start a real simple system here. The things arrive into the system, they wait in line, they get processed, and they leave the system. And I'm interested in the time and system, so I'm going to double click on this and the results. And then what I'm interested in is the average time in system, so I'm going to right-clicking, and you can see it adds two results. So now when I run a report, the time in system is going to be generated for me automatically. How do I run a trial and run a report? Under the home worksheet, you have a run trial. I'll trial setup, and I'm going to run the model so many different ways. I'll say 5 times, and then that is composed of one trial. So 5 runs make a trial. So think of the runs as individual runs of the simulation, and the grand experiment is the trial, and we're interested in the output of the grand experiment. So when I run this trial, you can see what happens. First of all, the model runs 5 times really fast. It turns off the animation. We don't follow that. And then it shows you the output of the last run, which is not that important. But what is important is that we have this results manager that pops up. And because I right-clicked on the time and system, the average, it gives me a report. And it's given me that for that particular run of 5, a trial composed of 5 runs, the average time in system was 232. And I can take that, and I can take this data and I can copy it. And I'm going to open up Excel. And once Excel is open, I can paste this. There you go. And it shows these are the outputs you saw. This is what we were interested in. So columns A, B, H, I, and J show you the same thing that you saw in this report, but it also gives us the individual runs. We don't generally need those. I'm going to delete them. You don't have to, you can hide them or delete them. So this is a report. And again, if you had a whole bunch of different things that you pulled in, then you could start building some graphs. You can use Excel like Excel is designed to use. Okay, I think that's a good start. And we'll do specific videos for specific examples. Thanks.